So, hi everyone, my name is Aditya and my paper is on the comparing modular and end-to-end approaches for in ASR for well-resource and low-resource languages. So, in last couple of years, we have seen a tremendous progress of ASR, but there are thousands of spoken languages around the world. And in ideal condition, automatic speech recognition should support all the languages. But it, of course, need the label data, and ASR has been mainly developed for the well-resourced languages. But now the new models are coming, which are multilingual and they are support multiple languages. So if we see the model progress over the years, then initially we were using the hybrid ASR models, and we are using the supervised learning task, but now the from the XLSR to Whisper ASR, and now newly coming universal speech models from Google and massive multilingual speech data set models from the Meta, it has gained a lot of way. So but if we are consider it still lacks in the many languages which are sufficiently widespread and major. And while we are working on our project, its name is a sign-on project, and where we need to work with Irish language, and it does have the more than 1 million speakers in Ireland, but it still does not support with many models. So we wanted to check that how is the adaptation over the low resource and well-resourced languages with end-to-end models. And if I am comparing with XLSR, then XLSR was pre-trained with 3 hours of training data with Irish language, and it is spoken by 1.8 million people. In contrary, we are also working with Spanish language, and which is spoken by 486 million people, and it has 22,000 hours of training data in XLSR pre-trained model. So we also checked that, okay, what about the Whisper? So Whisper that works with based with zero-shot ASR without any fine-tuning. And Irish is not used in the training of Whisper model. So we try to fine-tune it with Welsh, which is a sister language of Irish, but it was the performance of Irish ASR, and we dropped that idea. So we had the question that are the hybrid or modular ASRs are still relevant, and while working with specifically for under-resourced language, for example, Irish, and well-resourced language Spanish, and which issues that hybrid or modular ASR can solve over the end-to-end ASR. So we are comparing the Kaldi-based hybrid ASRs with XLSR models, and we are using the 2 languages, which is Irish and Spanish. We are asking the questions that which model performs better over the test data and unseen data if they are trained and fine-tuned over the same amount of data. What are the issues of non-lexical word generation? For example, the word weekend that becomes a weekend, or hello becomes a hello in the output of XLSR. Is there any impact of self-use language model weights in XLSR? And how is the latency and the real-time factors when we are deploying the models which are trained on the same amount of data on the same infrastructure with and without GPU? We are for our experiments, we are using the same amount of audio data for the acoustic modeling, same text data for the language modeling. We are keeping the weights of the language model and acoustic model same for the baseline models. And we will check that if the non-lexical words in the output of XLSRs are increase or decrease while we are changing the language model weight gradually. For the Spanish ASR, we basically use the common voice corpus, and for the training that was 313.56 hours of audio file. For the test, that was around 50 hours of audio data. For the language modeling task, we use the Spanish billion word corpus, and which has nearly 0.54 million types, which has the frequency higher than 10. For the pronunciation lexicons, we use a dedicated G2P tool based on the speech assessment method for phonetic alphabet for the Spanish language. For the Irish, we use a combination of multiple open source corpus, that was Common Voice Corpus 10, Google Fluids, and the Living Audio Corpus. And by combining them, we had the training of a training data set of 13.5 hours, and where the testing data that was around 0.8 hours. We use a web crawl data set which has 0.12 million word types for the language modeling task, and those types have the frequency higher than 10. And for the pronunciation lexicons, we acquired 13,300 seed Irish pronunciation, and with the G2P models, we created the pronunciation lexicons for the other types. For the modular ASR training, we use the Spanish, for the Spanish ASR, we use Kaldi recipe, which was adapted from the Libri speech. For the Irish, we use Kaldi recipe, which was adapted from mini Libri speech recipe. There is not much more difference in that, but the hyperparameters are changed so that it can be accommodated with a lower amount of data. For the acoustic modeling, we use in both the models, we use a time-delayed neural network and combination of convolutional neural network. And for the language models, we use a 4-gram statistical language model. Whereas on the XLSR fine-tuning for both Spanish and Irish, we did the fine-tuning over the 300 million parameters model. And for the decoding, we use the same statistical language model, but also we did the greedy decoding. That means the decoding was done without any language model and with language model both. If you see that baseline results over the test set, then not surprisingly with XLSR that perform really well compared to Kaldi baseline. So if you are saying that the common voice test set or in the Spanish ASR, that was around 15.69% word error rate, that reduced to 6.85. And if you are saying that character error rate, then in the Spanish ASR, that is we can say that it's really the same kind of results. Even in the Irish ASR, the word error rate that was decreased drastically compared to Kaldi baseline. And with respect to character error rate, the word error, the character error rate that also reduced and showing the same kind of results. But we wanted to check that if the language models weight can affect the non-lexical words. We are defining the non-lexical words are basically the words which are the part of our transcript, which are generated from the XLSR, but they are not exactly the words. So when we are not using the language model, then the non-lexical words that was around 6,220, which was the highest. But by keep increasing the language models, we are able to see that at the 0.5%, I mean, by giving the 50% weight to acoustic models and language models, the non-lexical words were quite reduced, but they are not completely eliminated. We see these tendencies in the both Spanish language and Irish language. But testing over the unseen data for the under-resourced language, Irish. So we basically try to gather the training, the testing data set from the Irish speakers, and we gather the 100 utterances from the different regions of Ireland. From the 4 speakers, and 2 of which they were Irish. They have the native Irish proficiency, and the other 2 has the very limited Irish proficiency. In that case, we saw that the result has been changed, where the Kaldi baseline was performing way better than the XLSR, where the word error rate that with Kaldi was around 29.56, but XLSR that was 33.77. But in the contrary, the character error rate of XLSR models that was better than the Kaldi results. That means we can think about with the output of XLSR that can have the multiple homophones and a lot of spelling errors. We also try to deploy both models over the on the same infrastructure. our efforts that where we can keep the same infrastructure and the minimal infrastructure, so without using any GPU in the backend, which models that can perform the best. The reason behind not to using the GPU infrastructure is that the project which we are working is a multimodal and multilingual, and where multiple languages are going to be used at the same time. So we wanted to keep all the infrastructure very minimal. And we can see here that with Kaldi ASR, the latency is quite low, whereas on the wave to wake with the latency of the models is comparatively very high. But if we are using the GPU in the backend, then indeed the latency issues that can be mitigated. So in our conclusion, we can say that for the under-resourced language, the Kaldi-based models that can still be relevant if you can define your own lexicons, and because with wave-to-wake models, non-lexicon word generation can be an issue. They can be reduced, but they cannot completely eliminated. Why we are much more focused over the non-lexical words, because we are working in a project where the input can be the spoken audio and output can be in a form of a sign language, where the sign language recognition is still, or the sign language synthesis is still not that developed compared to automatic speech recognition. In that case, providing the a perfect output from ASR that can be a that is very important. So and last thing is that Kaldi-based models are also having the lowest latencies, and they can be deployed with a minimal infrastructure. In our future work, what we are working is that we are trying to create a methodology where we can ensemble hybrid models with XLSR based on the rover techniques. Those words, this work has already been completed to a large extent, but yeah, we still need to find that what are the effects of the output from the rover on the non-lexical words. So yeah, that was it from our side. Thanks.